Hi, I'm Cassie, and I'm going to walk you through question 16 of the AAMC official physics question pack. So again, this question is related to passage 3 of the physics question pack, which is all about testing your understanding of the Doppler effect and various concepts related to that. So this question in particular wants to get at if you understand the difference between radio waves and sound waves and how that relates to Doppler effect. Well, radio waves, we know, and you should know, be able to draw the electromagnetic spectrum like I included here on the board. Like when I was studying, I would just draw out this spectrum to make sure I knew that, radio waves fall on the left and gamma rays fall on the far right. And, as you increase frequency, you increase your energy of your wave. And so you should know those basic kinds of understanding about how the electromagnetic spectrum works. And if you already had that understanding, you would know that radio waves are on this spectrum. So all these things on the spectrum, from radio waves all the way to gamma waves, they're all various types of waves of light. And what do we know about the speed of light? Well, we know that the speed of light is 3 times 10 to the 8th meters per second. Okay, and that's just one of those, quantities you got to memorize for the MCAT. You should have that down just off the top of your head right away. And the speed of light is always 3 times 10 to the 8 meters per second because light is traveling through a vacuum. And to simplify, you can just think of a vacuum as like nothingness. And so if something's traveling through nothingness, it's always going to travel at the same speed, right? Now, notice that on the other hand, sound waves are not on this spectrum because sound waves are different than light waves. Sound waves at room temperature are going to travel at about 340 meters per second. Okay, so what do you notice? What kind of waves travel faster? Well, light waves travel a heck of a lot faster, many orders of magnitude faster than sound waves, right? And why is that? Well, sound waves, as compared to light waves, which remember, light waves travel through a vacuum like nothingness, so they always travel at the same speed. But sound waves, they can't travel through a vacuum. They need to travel through some kind of medium. So typically, what kind of medium do sound waves travel through? They're going to travel through air. And those particles of air that the sound has to travel through are going to slow down those waves as they travel. So that's why sound waves simplistically travel much slower than light waves. And their speed of travel depends on what kind of medium they're traveling through too, unlike light waves. Okay, so we know that sound waves, they travel more slowly. And so therefore the answer is going to be A. Sound waves travel more slowly than radio waves because sound waves travel through a medium and radio waves are on the electromagnetic spectrum of light, so they travel through a vacuum and therefore can travel faster. But I want to make sure you understand why something that travels slower, so a smaller value number, is related to having a greater percentage change of the frequency and wavelength. And to do that, I'm just going to give you an example with simple numbers. I'm not going to use actual numbers for sound waves versus radio waves because they're big numbers. Let's just do an even more simple example. So we know that sound waves travel slower, so let's pick a smaller number. So let's say our original value for a sound wave, again, frequency or wavelength, we're just going to say was 10, versus our original value for our light waves was a bigger number since they travel faster. Let's say 1,000. Now let's increase each number by 5 and look at the percentage change, right? So if I take 10 and I add 5 to it, I get 15, of course. Versus if I take 1,000 and I add 5 to it, I get 1,005. So what was my increase in each case? It was just 5. So, but if we do percentage increase, right? To do percentage increase, you look at your increase, so what the change was, divided by your original value, and then times 100%. With the slower sound waves, the change was 5, the increase was 5, but my original value was 10, so that's a half, right? And if I times that by 100%, I'm going to get what? I'm going to get a 50% increase, okay? But now if I take those faster light waves that had that bigger original number that we only added the 5 to, well, if I take my change, which is 5, and I divide that by my original number, which was 1,000, and then I times that by 100%, what am I going to get? I'm going to get an increase of 0.5%. So look at that difference. For my faster light waves, which are bigger numbers, when my percent increase in something like frequency or wavelength would only be 0.5% versus for my slower quantity, my smaller numbers, my sound waves, the percent increase was 50%, which was much larger. So that's just to make sure you understand like the full concept tested by the question. So I hope this helps. If this helps, give it a like and follow my channel for more content like this.